In this movie, we'll look at deployment diagrams and why we might want to use them. To start with, I'll look at how you can use them to model the physical hardware elements of a system and the communication paths that connect that hardware. Then we'll look at how you can use them to show what software is deployed onto what hardware. This includes execution environments, which represent software like operating systems, application servers, or databases that act as containers for other software, and also the other software artifacts that are deployed onto them. These two aspects can be combined to model the technical architecture of a system in terms of hardware, software, communication, and dependencies. Finally, it's worth pointing out that in the same way as you can model classes and objects, you can model the types of hardware and software that will be deployed in your system, and you can model the specific instances that will be or are configured in a particular environment. In deployment diagrams, we show deployments, and those deployments consist of targets onto which we will deploy software and artifacts that represent that software. Starting with the hardware, a deployment diagram can show nodes and devices that will exist in the system. Nodes and devices are essentially things with computational power, and in the world of the Internet of Things, that could be anything from a powerful server down to a light bulb. We use communication paths to show the connections between the nodes and devices over which they exchange signals or messages. So a diagram like the one on the right here shows a number of nodes and focuses on the hardware and connectivity in the system. Deployment diagrams can also show software in the context of the hardware that it's being deployed onto. Execution environments are containers into which other software is deployed. They can be things like operating systems, virtual machines, app servers, or database management systems. The software that we deploy into execution environments or directly onto devices is represented by artifacts. An artifact could be a simple file, or it could be something that assembles code together for deployment, like a Java jar file, or executable code, like a .exe file or a .dll file. This way we can show what software is deployed onto what hardware. There's a relationship between the components in our component diagrams and the artifacts in our deployment diagrams. Artifacts are said to manifest components, so a Java jar file called x10coms.jar manifests the x10coms component in this diagram. The artifacts are the elements that we show in the deployment diagrams on nodes, devices, or execution environments. We can bring this together to produce diagrams that illustrate aspects of the technical architecture of the system, illustrating and documenting the physical hardware, the connections between hardware elements, the software that's deployed onto that hardware, and dependencies between software elements. Deployment diagrams can show either types or instances. In the same way as we can show classes or objects, which are instances of those classes, we can show nodes and devices in deployment diagrams that represent the generic types of nodes and devices, as on the left here, where we have controller, X10 network, induction sensor, on-off device, and open-close device. Alternatively, we can show the specific instances of those elements that we plan to deploy or that are deployed. So here on the right, we have the home automation set up for a particular customer, with an instance of induction sensor called entrance, two instances of open-closed device called front gate and garage door, and an instance of on-off device called external lights. We could add other pieces of information to this, like network addresses of the devices, to produce a specification of the architecture for a particular implementation. So let's have a look at how we would do this in practice in the next couple of movies.